In the spring semesters of 1989 and 1990, I taught an honors level non-majors chemistry course that was clustered with the required philosophy course that the same students were taking. And that meant that I sat in on Professor John Drummond's lectures and he sat in on mine, and we tried to contribute to each other's classes and make connections whenever we could to the other academic discipline. And I picked up a few things that enriched my general chemistry course. Here's one of them. If you're a science major, you're probably going to have a requirement in your senior year where you have to present a seminar or give a poster, and you're representing yourself as an expert on some very narrow topic. And if it's the first time you've ever done that, you're probably going to be nervous. That's kind of understandable. But what's going to make you the most nervous is the question and answer part at the end, because anybody can ask you anything about that topic, and as much as you prepare, someone is bound to ask you something that you haven't prepared for, and that's kind of scary. So what we're going to talk about today is different answers you can give to questions. The first answer is, I don't know. And I don't know is a perfectly acceptable answer. You can give that answer as often as you want because the most important thing is scholarly integrity. You don't want to fake it. So I don't know is actually a perfectly acceptable answer. Now you'd want to follow it up by saying, well, look at this reference over here or this source over here. That's a place you might find the answer to that question. So you want to try and assume the person really does want to know the answer to the question and follow up with some information on how they could find out. Another answer that seems superficially similar but is really quite different is nobody knows. And the distinction between those two answers is a distinction that's important to scientists. Maybe you wonder where scientists come up with all the ideas for the kind of research they should do. Certainly if you go to graduate school, you'll be asked to come up with a research topic, and the first time you try to do it, you will be totally clueless. So how do scientists come up with things to do research on, new things they want to learn about? Well, they are absolutely involved in all the research they do, and they think about it constantly, and they have colleagues around them that are thinking about it all the time. They're talking about it in seminars. They're talking about it when they go to lunch. They're thinking about it all the time. And in those conversations, somebody might ask a question, and a silence, a hush falls over the room, and everybody realizes that nobody knows the answer to that question. And that's important because that's where you get ideas for new research projects. So that's an important distinction for scientists. There's yet another answer that seems superficially similar to the previous two, but is really quite different. And that answer is, it is unknowable. And the distinction between these two answers is a distinction that's important to philosophers. Before 1925, people thought we lived in a world where every question could ultimately be answered, a deterministic world, a world of cause and effect, where everything had a prior cause. So if you knew enough about a system, you could figure out what would happen next. That's called an epistemic world. From the philosophy word epistemology, how do we know what we know? Epistemic means we live in a world where we can know anything. Well, since 1925, educated people have changed their minds about that. We now think that we live in a world that's not epistemic, a world that's not deterministic. Is it going to be raining at noon 90 days from now, right outside of your house? I don't want you to try to answer that question. I want you to think if it's even possible to answer that question. Because like when I was a teenager, you would get the weather forecast about 3 days in advance. And it wasn't completely reliable, but it was better than random chance. It was decent. And now, You can go on the Weather Channel website and get the weather forecast 10 days in advance. And it's not perfect, but it has some reliability. So we're making so much progress because our computers are so much better and so much faster, and our computer models for the weather are so much better. So yeah, 90 days, we can't do that now, but ever? Like 50 years from now? Couldn't we answer it then? Or certainly in 100 years, right? Or absolutely, definitely in 500 years, right? Well, maybe not. Because there are small, random fluctuations that occur in the motions of atoms. And if enough of those happen, if enough of those effects propagate over time, it could actually change the weather in ways that, well, they're not predictable because these fluctuations are random. What would cause such random fluctuations that make it impossible to know what the weather would be like 90 days from now? It's the Heisenberg uncertainty principle that states that it's impossible to know both the position and the momentum of a particle at any time.